Hello there. In this video we're going to be solving yet another genetics problem. This one is also regarding Mendelian genetics. The question is quite large, so I'm just going to read it out loud and write down the important information. Now it says here, fur color in Babbits, a hypothetical furry pet, is determined by a pair of alleles, capital B and little b. Now BB and B little b Babbits are black. It says big B, and big B and little b will give you black Babbits for fur color. Now it says little b and little b Babbits are going to be white. A farmer wants to breed Babbits for sale. True breeding white Babbits, the little b ones, are bred very poorly. So the farmer purchases a pair of black Babbits, which mate to produce black and white offspring in a 3-to-1 ratio. So the farmer just bought two Babbits, and when they mated, they produced offspring that were both black and white. Now, whenever you have a 3-to-1 ratio of offspring with phenotypes, this tells you that it's actually a heterozygous cross, which means, in this case, the black Babbits are going to be big B, little b, crossed with another big B, little b, which means the male or the female, the parents both had this type of genotype. And we determined this based on the phenotype ratio of 3-to-1. Now it says, at the end of the question, the farmer immediately sells off all the white Babbit offspring. So let's go ahead and make a Punnett square quick. So the thing you want to keep in mind is the farmer sold off the white Babbits. The white Babbits have a genotype of little b. So in our Punnett square, when we crossed the two black Babbits, the parents that we determined were heterozygous, we got the little b's right here. So these guys right here were sold off, so they're not even here anymore. And we're just dealing with the black Babbits, because those are the Babbits the farmer actually wants. Now the question is, if the farmer performed a random cross between the remaining Babbit offspring, these guys right here, it says, remember the white Babbits have been sold, so what proportion of the progeny would be white? So if the farmer started doing random crosses with all these guys here, what is the probability that they're going to be white? Well, let's just take a look and say, well, what crosses between all of these types of offspring can actually give you white Babbits? Well, if you think about it, the big B is dominant, right? So if you cross, let's say, big B with big B, little b, you're only going to get black Babbits. So that's not going to work out. The only situation where you can get white Babbits is if you have a homozygous or homozygous recessive thing like this, little b. And you can get that if you crossed this one here with this one over here. So what are the chances that if the farmer picked one random Babbit out of a bag or something, I don't know what's going on there, what are the chances it would be one of these two? Well, if there's three possibilities, this one, and this one, because remember, the white Babbits were sold off. So we only have three possibilities. So that would be 2 out of 3. Because there's 2 heterozygous ones and 3 possibilities. But since the farmer needs 2 Babbits to actually mate them, we're going to be multiplying this by 2 because the farmer's looking in the bag twice. Now this is just the probability that the farmer is going to get 2 heterozygotes in order to actually produce the white Babbits. But now we have to, Now we have to check the probability of actually getting a white Babbit. So what's the probability of getting a white Babbit if you crossed the heterozygotes, the black Babbits right here? We already have a Punnett square for that. It's right here. So let's just reuse this one. We noticed that these Babbits right there are white, so that'll be a 1/4 chance because all these remaining Babbits are black. This is the only white one. Therefore, we multiply this by 1/4 again. Now, if we actually did the math, we would get 4 out of 36. And if you simplified that, that would be 1/9. So we have one last question. If the farmer crossed one of the male offspring, remember the white Babbits have been sold off, with the parental female, what is the probability that this cross will produce white progeny? Alright, so we know that the parents both have heterozygous situations. They have big B, little b. So what we're talking about is a cross between this one and something else that would actually produce a white offspring. Now, we can't cross it with a heterozygous dominant thing because all the offspring are going to be black. So it has to be another heterozygous situation. So again, what is the probability that you would actually get a heterozygote Babbit if you picked one at random? Well, that's going to be 2/3 still. So it's going to be 2/3 chance of grabbing one of the heterozygotes here. And then we have to think about what's the probability that if you cross these two, that it's actually going to be white. Well, that's again going to be 1/4. So if you multiply this through, you're going to get 2/12 or 1/6. So this again is the probability that if the farmer crossed one of the male offspring, remember the white Babbits have been sold, to one of the parental females, so one of the parents, what is the probability that this cross will produce white progeny? So thank you for watching. If you have any questions, feel free to ask in the comment section below. And I do hope you're having a fantastic day.